Who are you?
My name is Chinh, and this is Stephanie. And our project was a 2-axis CNC device powered by network with WizNet. We wanted to do this because CNC machines are expensive, they're rare, they're big, and not everybody can have one. And we also wanted to know what it takes to build one. So we built this device, and we also wanted to incorporate network control so that any home user could send a project through the internet to a place that has a CNC machine and create a product directly instead of going through the typical manufacturing process of making drawings and sending it to a machinist. And it takes a long lead time. Here, you're sending your product directly to the machine.
So do you want to show a demo while I explain?
Sure.
Okay.
Hold that microphone on.
All right.
So, what are you dialing in here?
So this is connecting directly to the server.
I can explain.
The connection is confused.
So what he's doing here is he's using Telnet to send G-code, which is basically hardware code that controls CNC. So he's going to send some code, and it will be routed through the router to the WizNet module, which supplies the IP address. And from the WizNet module, we're using that as a master, and we're sending the serial into another Arduino. This Arduino here serves as our G-code interpreter. It'll take the G-code, which is sent through the serial line, and then in turn move the stepper motors.
Alright, so standard Android phone, and it's powering our machine.
So can I see, can you show me what you're looking at on the phone?
So basically, this is just a standard Telnet server. It connects directly to the router, which connects to our WizNet module, and we're sending basic G-code. This one is just telling us to move 4 inches on the Y-axis. So I just hit send, and the Y-axis moves 4 inches. Now, here's a more complicated G-code. This is the G-code for a circle. So we're going to try to send that in and see if it can draw us a full circle. There we go, that's a circle.
Slightly crude, but needs a little tuning maybe.
Yeah, so we found some difficulties with the control of 2 stepper motors at once. We found a little bit of difficulty controlling 2 stepper motors at once because they both have to step in opposite directions at the same time. So we're actually using 3 different drivers on this unit. We may have been better off using a screw drive system, but we wanted to be adventurous and come up with our own belt design.
So what you guys learn in all this?
We learned that the coding for the G-code is actually really complicated. We're going through the program, and it's about 3-4 pages long, and we're just trying to figure out how it interprets the simple code and turns it into an Arduino movement. And that took us at least 2-3 days. And another issue we're having was the power to the stepper motors. We weren't having enough power delivered, so sometimes our system wouldn't move as we thought it would, and we were trying to troubleshoot, and we spent hours thinking the motor was stuck or something.
Yeah.
What did you get out of this?
Probably the most that I got out of it is how powerful open source is, because basically what we used for the G-code interpreter, it was already available in the RepRap library. They created an Arduino G-code interpreter. So we adapted their library so that we could use it on our system. So it shows how flexible that all these open source programs and libraries are to somebody who's just in a mechatronics class and trying to make something work within less than a semester.
All right, very good. So you guys make sure you document everything you record. We'll use you guys as an example for someone else next time. All right, thank you very much.
You guys see it move some more? You can actually send more detail for it.
guys ought to show this at the Maker Faire. How is that?
Oh, it's up in San Mateo.